Okay, suppose you're here at point P. You need to get to point Q. Now, we're sailing there, and typically you don't sail in a straight line. Is there any way we go from P to Q sailing and never go in the same direction as the straight line going in between? Well, the answer is no. Because as we look here, we would be in that same direction right here, because that's our tangent line slope. And in this case, oops, also right here. So there'd actually be two spots we'd be going in the same direction. This all leads us up to what's referred to as the mean value theorem. I'm not talking like a nasty theorem, not that type of mean. But the mean value theorem states that if it's differential, meaning your derivative exists, so that means there's no cusps, no vertical asymptotes, things like that, and it has to be continuous. So you have a differentiable and a continuous function, and you know your two endpoints. Basically, it's saying your slope between your 2 points, and that's the normal slope between these 2 points, has to be equal to the slope or your derivative, somewhere in between here. That's what the mean value theorem is saying. So that your slope between the 2 points has to be equal to your derivative somewhere on the interval between A and B. So let's go ahead and apply our mean value theorem to this. But first of all, you got to check to see if you can. First of all, it has to be continuous. Oh, but we got problems here. We're dividing by a variable. So we know whenever the bottom is 0, it's not continuous. So what would cause the bottom to be 0? Well, that would be 0. But that's not an issue here because our interval only goes from 1 to 3. So our function is continuous on the interval of 1 to 3. So it's continuous. We do have a closed interval, so that's good. Would your derivative exist? Well, let's go ahead and take a look at our derivative. We know our function. We could take each one of these over our x, ends up being this. Now we take our derivative of 1 is 0, take our derivative here, put the exponent in front, decrease the exponent by 1, 0 doesn't make a difference. We get this here. Oh, this is our derivative. Would our derivative exist between here and here? Well, we got variables in the bottom, so that means we got problems. Whenever the bottom's 0, which in this case would be x being 0. But that's not an issue for us because 0 is not in our interval. So our derivative would exist between 1 and 3. So it is differential. So it's differentiable, it's continuous, it's on a closed interval. So the mean value theorem says our derivative, oh, we just figured that out over here, has to be equal to our slope. Oh, well, that's pretty easy. If my first x-coordinate is 1, plug in 1 here, and I get the y-coordinate of my second point. Here, my second x-coordinate is 3. Take that and plug it in here. And I get this here. All I have to do is find my slope. I know slope is change in y. Subtract my two y values over change in x. And then I have to go ahead and simplify, and I get this. So the mean value theorem says my derivative has to be equal to my slope. So I got to set these equal to each other and solve it. And I should get an answer in between these two here. So I go ahead, set my derivative equal to my slope. No, the negative 1's drop. Flip both sides or cross multiply, doesn't make a difference. Take the x squared over here, take the 3 over there. Take my square root, remember the plus or minus, and our only answer is going to be the positive root 3. Since the negative root 3 is not in our interval, positive root 3 is about 1.7, and now 1.7 is between 1 and 3, so that's good. So that's our mean value theorem. It says your derivative has to be equal to your slope. And what causes your derivative to be equal to your slope is going to be somewhere in between the two endpoints here.